Hey crazy kids, how's it going? Hope you're doing well. So what I'm going to do is I'm going to switch things up just a little bit. There have not been a ton of people that have been watching these videos, not surprisingly. So I am going to just start going through one task every day. Just slow down a little bit because I guess we're just not really in any hurry at this point. So these will be pretty short videos. Again, just optional for you if you want to, keep your brains fresh and keep your parents off your back, so you can tell them, hey man, I'm doing something every day. I'm doing my math homework. Okay, if you watched yesterday's video, it strangely cut off right in the middle. Sorry about that. But now we're back on track. So it says, what key features of the graph does each form tell you? So standard form, I'm sure you recall, is the form y equals ax squared plus bx plus c, and that tells you the y-intercept, and that is whatever c is, that's the y-intercept. Okay. Whoa, where did that go? There we are. Okay. Then factored form looks something like this. X minus, I don't remember what letters they were using for this. B and C maybe? I guess it doesn't matter. X minus B times X minus C. I want to use the same ones because those are a little bit different than, did I do that here? No. Alright, so it doesn't matter. Just do whatever I want. No rules anymore. Anyway, factored form looks like that. And what this does is it tells you the x-intercepts. And those x-intercepts are B and C. Okay. And then vertex form is the crazy looking one, y equals a times x minus h squared plus k, and that tells you the vertex. That's why it's called vertex form, and the vertex is at h comma k. So this one slide right here is what this whole unit is all about. You know these things, and you can rule the world. Okay, so let's put those to work. On task number 9, we're going to make a graph of each one of these things. So this one is in vertex form. So that means it tells us that the vertex is at 3, 1. So we'll put a dot at 1, 2, 3, 1. I like to use this bigger, a little bigger dot going there. Okay, so that's the vertex. We don't know anything else about the graph though, and that's why it says find and plot 3 more points to sketch the parabola. So I'm going to plug in x values that are close to this one. I'm going to plug in 4. I plug 4 into there. 4 minus 3 is 1. 1 squared is 1, and 1 plus 1 is 2. So when I plug in 4, I'm going to get 2 as an answer. So I could do the same thing. I could plug in 2 and then go 2 minus 3 is negative 1. Negative 1 squared is also 1, plus 1 is 2. I didn't really have to do that though, because I know the vertex is right in the middle of the parabola. So if this point is on the parabola, then there's also going to be a point over there. Okay, and then it would like us to do one more. So let's stay in the neighborhood. Let's go ahead and do 5. So 5 minus 3 is 2, 2 squared is 4, 4 plus 1 is 5, so that's this point right here, and then I'm going to have to, by symmetry, that point on the other side of that as well. So let's get fancy here and use some technology to make this graph. That's not what I wanted. Okay, so I got to start at the vertex maybe, and then go up. Not great, but we can make that fit. So that means it's going to look, oh, money, baby. It's going to look just like that. All right, for this next one, this is in factored form, so it's going to tell us where the parabola would cross the x-axis, and it's at the opposite of these two numbers. So it's going to cross at -1, and it's also going to cross at -5, okay? So then what I'm going to do is I'm going to figure out where the vertex is. I know the vertex is going to be right in between those 2 points because it's symmetrical. If I plug -3 into both of these, -3 plus 5 is 2, -3 plus 1 is -2, and 2 times -2 is -4. So that's going to be my vertex, okay? Okay, now let's plug in -2 just to stay in the same area. So -2 plus 5 is 3, -2 plus 1 is -1, and multiply those together and I get -3. So that gives me a point there, and then by symmetry there's going to be another one there. So what if I start over here? Oh, that works. Okay, so there's my parabola there. And of course that would, extend up past that. Okay, so now let's do the same thing, but this time let's write an equation. So since they're giving us the vertex, we're going to write an equation in vertex form. The first thing we know is that y is equal to some number a times x minus 6, because that's the x-coordinate of the vertex. That whole thing is squared, minus 4. So now I need to use this other point right here to figure out what a is. So I'm going to do that by plugging the 5 in for the x, the -1 in for the y, and I'm going to solve for a. So if I do that, I get -1 equals a times 5 minus 6 squared minus 4. So 5 minus 6 is -1. So -1 equals a times -1 minus 4. Then -1 squared is 1. So the next line would look like 1 equals 1a minus 4. If I add 4 to both sides, then that tells me that a equals 3. So, final answer for this one would be y equals 3 times x minus 6 squared minus 4. Okay, next one has roots at -2 and 1. And roots are a fancy word for where the graph crosses the x-axis. So I'm going to go y equals a times x plus 2. And then I'm going to do times x minus 1. The fact that it has a y-intercept of -3 means that when x is 0, y is -3. So plug those into there. -3 equals a times 0 plus 2 times 0 minus 1. So -3 equals a times 2 times -1. So that means -3 equals -2a. And if I divide both sides by -2, that tells me that a equals 3/2. So now I'm just going to write that as a final answer. So y equals 3/2 x plus 2 times x minus 1. Okay, then if I only know that it passes through these 2 points and I don't know another third point on the graph, then it turns out that I can't come up with an equation for that parabola. Because if you think about it, if I know it passes through 2, 2, and 8, 5, the parabola could go like this, the parabola could go like this, the parabola could go like this. So there's actually an infinite number, I think, of parabolas that would go through those points. So I'm going to say not enough info. We would need at least 3 points to be able to figure that out. Okay. All right, let's try this one. Roots at 0, 5 and passes through the point 1, comma 4.8. So y equals, it's giving us the intercept, so I'm going to use the factored form. Y equals x minus 0 times x minus 5. And then if I plug in 4.8 for y, and I plug in 1 for x, then go 4.8 equals a times 1 times negative 4. So then 4.8 equals negative 4a. So if I divide both sides by negative 4, I get a equals negative 1.2. So write that out. Y equals negative 1.2 times x minus 0, which, yes, Aaron, you're right. I don't have to write the 0, but it doesn't hurt if I do. All right, and then the last one, and then we'll wrap this up. Just a short little easy day today. Vertex at 0, 5, no intercepts. Once again, can't tell you what that equation is, because if all I know is that it goes through 0, 5, doesn't have any x-intercepts, it could look like this, and that would work. It could look like this, and that would work. It could look like this, and that would work too. So not enough information. So the only way that you can do it if you know 2 points like that is if one of them is, well, I don't know. That's just not enough information. So, okay, and that's all I got for you today. Hope you enjoyed that, and hope you're taking care of yourselves. Hope you're doing well, and I hope to see you soon. Bye.